Instead of putting T1, T2, and just guessing what it is or having to jump back to the top of the method to figure out what it is, I'm just going to name it intentionally. And that's a good practice. You should be doing that already. But I won't lie, once you have this verbosity that exists in your application, sometimes you just want to get it done, especially when you're doing testing. I don't want to write tweet, tweet, tweet every single time. Tweet, tweet, tweet enough. Like, I'm tired of that. Let me just put a T, let me put a T1, T2, and move on. But now we don't have to do that as much because we have this local variable inference. And it kind of flows more contextually nicely because I have a variable, right? And I have tweet because I've named it intentionally. Later down in the stack, I know that it's going to be a tweet because I named it intentionally. And the compiler is happy with this because it knows the reference type based on what's on the right side of that equal sign. And so if anything, it just makes your life a bit easier. And as you can see, build 9 is the greatest ever to do it. I don't have to worry about build 9 anymore because like my tweet is already established. And same thing for tweet entity. As long as you're naming your things intentionally, the local variable inference types just make things a lot easier to rock with. So just a couple of quick notes. The idea is just to reduce the boilerplate that you have to do, kind of like with, if anybody's familiar with Project Lombok, it exists because they're trying to reduce boilerplate, the getter setters that you always have to have there. Similarly, now with JDK, I think this was in 14 that it came out, you don't have to write every single reference type on every single declaration. You can just do a var and do your same old declarations that you're used to. And it was found that within the JDK, they can replace local variables, up to 94% of local variables with variable instances. And mind you, it does not mean every local variable needs to be a var. I want to make that very explicit. That is not what I'm saying. There is a style guide that was published by the JDK team that tells you exactly when it is necessary. They have 4 principles and 7 guidelines to make it happen. It's literally a step-by-step guide. They acknowledge all the risks and assumptions that go with not losing that context of not having that type reference. So it's not a silver bullet. It will not fix everything, but it is important for you to know about because it can make writing code a lot easier for you as a developer. So let's see an example. Here we have a try with resources block. And notice in the top, and this is something I have done before, like I mentioned before, because you just want to get it done sometimes, especially if you're moving quickly. But we have input stream is, input stream reader, ISR, buffered reader, buff. And obviously on the right side, you know the exact type because you're creating new instances of those. Now, instead of doing that, because again, let's just say you're writing 5 tests and you have to replicate this 5 times. Sure, you can copy and paste it, but the idea for each test is that you're testing something different. So sometimes you have those nuances that you want to change. So going in and declaring it every single time can just get annoying, right? Not only that, but I'm also, I haven't been diagnosed, but my attention span is pretty bad. And so when I see a lot of words, I instantly get, oh, this is a lot. Okay. Like I like to just get straight to the meat. And so now with variable instances, you can just replace those. And with that, it forces you, like I mentioned before, to start naming things intentionally. So instead of IS, like what is it? I don't know. If it were later down the method, I would have no idea. I would have to go back to that reference. And God forbid it's a 1,500 line method that I have to jump back down to figure out what in the world it references. But now it's input stream. I don't have to jump back to the declaration to know what an input stream is because it's already named that. So if anything, it helps you as a developer write better code for those people that come behind you that won't have any context. Because the last thing you want to do is when an incident comes and you're having to go and try to explain things that you want someone to jump in with you and like know what's going on and you not have to handhold them the whole time. But let's just say the code is not being managed by you anymore and you don't want the next person behind you to hate you like just in another life because they're like, who is this Cavasier kid that put ISR? Like, why didn't he just write it out? That would have made life so much easier and it takes 0 time to do. This will make you, in a way, have that done. Now, this is something I mentioned style guides because it is very possible for you to like set a new standard across across a new repo or any repo that you have. And you have an idea to just make things more succinct. And I put this up specifically because if you want to see the change, you have to be the change sometimes. My dear friend Ryan would always say that. And I'm learning more often that when you want to see that change, more often than not, you just have to be it. So if you were going to implement a new standard for your application, specifically on local variable instances, specifically around your own styling, make sure you're consistent with it. Make sure your team knows about it. Document it so people know. And that way they won't have any excuse not to, number one, know about it, but 2, follow it because it's already written, it's documented in code. And so they have no reason to not know about it. Oh, whoops. Quick little side-by-side benefits and challenges. Like I mentioned before, it reduces your boilerplate code. It encourages the potential of variable naming, which makes everybody's lives easier, even people who aren't developers. And then dismantle complex chaining. If you didn't want to do, and this is more subjective, but sometimes chaining can get a little confusing depending on what you're doing, like strings, for example. Sometimes if you want to break those down and connect those specifically to variable instances instead of trying to figure out what that chain, that method called actually returns. You can just set it to a variable instance and again, intentionally name it so that way you can move on. If you don't take anything else from today, just remember the 4 C's for complexity, for challenges. Careless coders create complexity. Always, 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 always. We've seen it. I've seen it way too many times where people are just throwing stuff up and I'm like, I'm not approving that because I don't even know what this means. And I should know, I'm on the team. So imagine if someone else, another developer, were to come in and come behind you to say, I don't know how to make a change here. Well, they probably shouldn't be for the first place unless you encourage that. But also like another developer should be able to know what's going on. So moving on to the next one, we're going to get into pattern matching. So first, we're going to talk about switch expressions. With switch expressions were meant to simplify control flow logic, help with the scoping of variables, and then also release the traditional statements of switches from declarations and actually like to be able to return a value. And so you'll see in this first one, that break from dependency. We probably all, if you're a Java developer, you've probably all seen the standard switch statement. And one thing that always used to mess me up, at least, was I would always forget that break from time to time. So when that fall through logic that happens within switch statements natively, it would just miss me because we have a Monday, because you have so many different cases that apply to one thing. Sometimes you just want to return a value, right? And at least that's what pattern matching does. But the first step was to make it so that that control flow is more succinct. And so instead of having like the fall through of having Monday, Friday, Sunday, you were going to return a 6, you would use this arrow label, which is new with the switch expression, and then you would just print it. And it makes it, if anything, and I'm going to say this a lot, reading from left to right in the English language is easier to see things because now you're doing your evaluations on the left side and then you're doing your executions on the right. And so you don't have to, it doesn't take as much time to see what's going on because it's directly laid out and you can quickly grab the context of what's happening. For case Monday, Friday, and Sunday, we're returning a 6. In case of Tuesday, we're printing a 7. In the case of Thursday, Saturday, and so on and so forth. Now, as this continued to progress, specifically with returning values with switch expressions, they are exhaustive. So in this case, I have to imagine, I think I took this from the JEP itself. And JEP is a JDK enhancement proposal. That's how new features end up in later JDK versions. But it returns this value, and I'm assuming this is an enum of all 7 days of the week. So in this case, every single day of the week is here, and that will come into play later for pattern matching, but I just wanted to mention it now. Instead of having to declare an object outside of your switch statement, you can have that returned directly from the switch statement, which to me matches everything else that you've done within Java, right? Like if you declare a new variable, you have your left side or your declaration, and then you have the new instance being created on the right. Similarly here, you have the assignment of whatever the switch statement is returning assigned directly to num letters versus you having to assign it in every single switch statement block that there is. And it just helps, again, with that control flow, you as a developer of reading it, but then also it's optimized specifically for switch because now it helps us set up for the pattern matching, which we will get into next. So pattern matching offers a lot for us. Number one, if you've ever seen, and I'll talk a little bit about this, I'll have an example later, but if you've ever seen that instance of pattern where you have a general object and you want to map it into, or cast it rather into an object, a specific type reference, then it does that automatically for you in pattern matching. So you don't have those nested if else blocks. We'll get into that a bit. It also introduces pattern variables. So that's where that casting comes into play. And then extensibility of your logic. Let me show you an example. So likely if you are a Java developer, you've seen something like this on the left side. And obviously this is a very complex case. Like it's not something that we want to do at times, but sometimes like it just makes life and extensibility a lot easier for you as a developer and the longevity of your application. But now with JDK 21, you have more opportunity for you to map these over in a more succinct way. And so instead of doing the object instance of that you see on the right side, now it was introduced within switch expressions to have that pattern variable. So that pattern variable specifically that I have a pointer, that pattern variable right beside on, there's no lines either, line 3 technically, that integer I, that's that pattern variable that you're able to use if it's scoped for that case statement. So in this case, what's happening is it's for that general object that's being passed in that formatter method, we're passing in and then we're assessing each one to say, all right, object instance of integer, no. Okay, object instance of long, no. Object instance of double, it is, great. It's gonna match that double now object into that D, and then we're able to use it within that if else block. Now, you don't have to worry about that as much because with pattern matching, it goes through and it checks in more of a parallel way. And so it doesn't do it sequentially as if else. If we have a new object coming in, we can map it directly. And so what switch does is say, okay, does object match this integer? No. Does object match long? And again, it is done in a more parallel way. And so if it does apply again, it goes into that variable and you can use it directly on the right side. So it just makes things a lot easier. And again, this is exhaustive. And so it adds a bit of robustness to your application because you don't have to worry about the unexpected changes that could happen or the unexpected responses that you might have because it is exhaustive by nature. And your compiler will literally complain if you try to not catch all the cases. In this case, there's a default that obviously all the type references are not here, but there's a default clause to say, okay, if it's something that we can't cast it to, we'll just drop it and it's no big deal. And again, you don't have to worry about that explicit casting anymore because that was not a fun time at all. As an extension, there was also a time where we had to, it's not also a time because it still exists for JDK8, unfortunately. But you have to check if you were to pass in an object, and Java loves nulls. Not really. Everybody has seen that the dreaded MPE exception being thrown around here and there. And to avoid that, we have to paint our methods with that if it is null, then we need to do something with it or just bomb out, whatever, like handle it essentially. Now with the switch statements, we don't have to do that anymore. It's actually built in. And so now we have case null and we can do whatever with it, whether it be throw an exception. In this case, we're just printing a statement. But now it doesn't have to be decoupled from what's already existing in switch and it's built in. So once again, it makes reading your logic in a more succinct way a lot easier. And it's more efficient this way too, because now, again, you're running it all at one time. So if it is null, it gets treated just like the rest of them. And all the errors will be handled natively by the switch statement. Last example, once upon a time. Yeah. So there's always a case where, and again, if you're using switch statements, your application probably is a bit complex already. And so you never want to get to this point where you have cases or if-else statements within case statements. Like this just nested conditional logic that makes it really difficult to know all of your potential branching paths that could happen, but it happens. And I understand sometimes it's hard to get around and, you just deal with it, right? And so in cases where you have your pattern matching, as always, and in this case, we're mapping a string. Now, mind you, the input is a string too. So keep that in mind. But the input is a string, and if it does match to a string, assuming that it's not null, we need to do something else with it. We want a different response for every single one. In this case, we used to do if-else statements nested within, which isn't a fun time anymore. But now, with the improvements with JDK 21, we can do guarded case labels, where we have this when clause that exists on the left side on top of the case statement itself. And so what's happening here is basically effectively what that if-else is doing. The case is still checking for a string, so all of those will pass. But then only for that when clause would that right side of the block, the execution block, actually happen. So in this case, we check to see if it's yes, we check to see if it's no, and then if it's just a plain old string, we just print a sorry. The same way that you would have done with that if else, but now again, we're keeping that evaluation on the left side, and then we're doing that execution on the right. So it makes reading your code, understanding it, and then also implementing it a lot easier. That could probably be a bit subjective for people. I think it's a lot cleaner this way because, again, you want to be able to code for people behind you, like not just for that moment and get your project done, because someone at some point is going to ask for a new feature that's going to have something else scrap it, and you need to anticipate that. So a couple of benefits and challenges of pattern matching. Like I've said before, it helps simplify those nested conditional blocks. It's exhaustive, inclusive of null checks, so your code becomes more robust, and it helps reduce that redundancy and type safety casting. I had to mention some challenge. It felt wrong not to have something, and this was explicitly called out in the JEB, that sometimes with record patterns that were introduced in JDK 19, it's possible that the switch statement could bomb out abruptly, and it depends on how, for example, if you're calling a record pattern and you have an accessor method within that object, and it just does something silly. Like the example they use was like dividing by 0, which I don't know why you would do that. Can't imagine someone wanting to do that at any point because it'll never work. But that was an example that they use. Like it happens so infrequently that it's kind of silly to mention, but I felt it necessary to at least mention here because it isn't perfect. Nothing's perfect, but it will help you in several other ways to make your code more robust and easier to read. All right, last thing I want to talk about is virtual threads. And I think virtual threads are really cool. And I'm actually kind of sad because I haven't spent enough time getting to know them a bit, but I did a slight experiment to get going. Essentially, the picture does it a little. Oh, I don't have the picture. Sorry. Okay, I'll describe it a little bit. So basically the the JVM uses platform threads because Java is a multi-threaded tool. And instead of having a platform thread, which are expensive and are limited dependent on your hardware, the JVM will create virtual threads per platform thread, depending on what your throughput is. And so the virtual threads are meant to be lightweight. They can be easily created and easily spun down like immediately. And the idea is that for applications that have non-blocking operations, you are able to continue to process things at a rate instead of having that one platform thread wait for something to respond back to and just wait. It spins up a separate Java thread, does a context switch, and it continues to process requests that are coming into your application. So let me show you what that looks like. So I use a tool called Locus, and Locus is a load testing tool, open source load testing tool written in Python. And I already had an application that's where that tweet block came from earlier. And I just wrote a small little Git API. And all it does is sleep for a second. And that is to mimic an intensive CPU operation that you might have, right? It mimics some non-blocking operation happening downstream. So the thread is waiting effectively, and then it returns the current thread. And that was the current thread name back to you, because I wanted to check to make sure that the platform thread was actually virtual versus a platform. And it does work, which is insane to me. And what I did, my test was to do 1,000 concurrent users. So effectively every second, 10 users would get spun up, and those users would start hitting my application nonstop. And you'll be able to see that in the graph on the next one. Now, I did that for 1.5 minutes. It was not even that long of a time, right? This was without virtual threads enabled. If you notice on the top side, I have requests per second that reached about 200 milliseconds. 200 requests per second. And then there's a 95th percentile and a 50th percentile. They were pretty close for the most part. But you notice right at about where it started to reach that 200 requests per second, it started to have more latency. So this bottom, remember, I'm sleeping for 1,000 milliseconds. And so sitting at the percentiles at 1,000 milliseconds makes sense because it should be pretty quick. All I'm doing is printing it. And then sleeping it and then returning the response back, which from the thread. So it should be very speedy. I'm not doing anything downstream other than sleeping it. And notice the latency started to go up at 200 requests per second. This is just platform threads. Check out what happened when I did virtual threads. That line remained consistently. And not only that, the requests per second continued to go up. And natively, Locus will notice that your application is starting to slow down. So it'll stop sending as many requests. And Locus noticed when I switched over to virtual threads, it was like, oh, you're handling this great. Like your latency is not changing at all. And mind you, this was only 90 seconds. So who's to say how long it would have been able to do this for? I'm not quite sure. But I think noticing that change already, and I think that was like within a minute, like just by enabling virtual threads, just goes to show how powerful they could be for your application when used in the correct way. And the funny thing is enabling it is as simple as a config change, which is the most, like, I could not believe it. And that's why I bid that print statement back. Because I was like, there's no way it's that simple to just enable virtual threads. There's absolutely no way. But it is. It's literally a config value, Boolean, true or false. So if anything, it just talks about, it really emphasizes how much the JDK package has advanced itself. And it really wants to have specifically with Project Loom, have a stake within this concurrency, asynchronous processing world that we're starting to live in, because people want things now, and we need to be able to handle that high scalability, high traffic areas if we want to be able to compete in the markets nowadays. And that goes for any application or industry that you're in. So wrap up, I have a couple of references, just things I use. And obviously, Jeff, the Java team is awesome. Like they always have previews up. Right now they're doing primitive pattern matching for a release in JDK 24, at least they're saying it is. And then the long-term support, JDK 25 comes out next year in September. So things are constantly evolving. If you're not missing out on all these features, then you got to have that conversation with your manager to get it going. So that is all I had. Feel free to connect with me. I got the LinkedIn up here. And thank you. Do I need to cut this off?
Yeah, I think you leave it on the
Okay, thanks. Oh, I guess I didn't ask. Any questions about anything she chatted about?
So I don't have a question, but I'm a JavaScript developer, and I've never dealt with Java ever. And this new update, you're like, oh, it looks I was able to rate it easier. Oh, it looks like JavaScript.
Yeah. I'd say they're similar in that like simplicity in reading for sure. Java's obviously strongly typed. Like the wild west of JavaScript, I still have problems with sometimes, but that local variable inferences kind of gets into it. So that way it just becomes easier to write things. Like that's one thing I do like about JavaScript. Like you just declare const, let, like, and just name and run. Yeah. Literally, yeah. That's that's why TypeScript came in to give it some bounds. Yeah. So any other questions?
So one thing I do, at least in my team, to try out these new features is to put it to the JUnit test cases. So like low risk, right? Everybody's scared of changing everything. So like especially when streams came out and this switch statements came out, it was like easier to say that, okay, this is something that we can do. Do you have other tips like in a team environment to make this transition?
I'd say like the biggest thing for our team was just testing. So we do hackathon projects where we just take like 2 days, and if we have a feature we're interested in, we just slam it. Like we'll throw something in our test account, run load tests. Like I said, we use Locus at work. We use Gatlin. We're starting to get into Playwright too, and just like test the heck out of it just to try to mimic the current traffic that we're getting. And that way, if we're going to make that transition, we're going to start writing features for it. Like we have some kind of POC and data to back it up. So that way we could tell it to upper management. So I say, yeah, taking the time to test. And if there's something specific you want to try out, like, yeah, give space for your developers to make it happen. That'd be good. Cool. Any other questions?
Have you compared your testing tool against something like K6? Have you seen K6? Is it similar?
No, I'm not sure. I don't think I've seen K6 before.
Grafana has a tool called K6 that we played around with a little bit for load testing. Just wondering how similar it was.
Is it open source too? Or?
I think so.
Yeah. Okay. I'll check it out. I'll keep a note for it. Yeah. Yeah. I was going to show it because like the setup for Locus is super lightweight. I'm actually shocked by it. It's kind of similar to virtual threads. I was like, this seems way too easy. Because I think the test already existed for my team before with Locus. So I was just adding on to it, but doing it from scratch, I was like, man, no wonder they did this. I love this stuff. It's cool.
So distrusting of things when it works immediately.
Tell me about it.
Every time
Right?
it works, I'm like, wait, what's wrong?
What? No, seriously. It seems too good to be true. Yeah. Every time. I've been burned too many times, I guess. So, yeah. Cool. Any other questions? Sweet. Thanks, y'all. Appreciate it. Right on time.